Hello all, this is a presentation for Advanced Deep Learning project. Our project is the knowledge representation of neighborhood through graphs. So as a part of creating a surveying a neighborhood, we have made use of 311 calls to identify the problems through 311 call case descriptions. So to start with, we have collected the data from Open Data KC. So this data gets updated every day. So we can download this as a CSV, and from that data, we can see that it has case ID, source, department, and latitude, longitude, all that information, along with what is the time it takes to resolve um, the close date and the time it takes to resolve a particular case. So yeah, let's see this, the zip code, the neighborhood, the county information, and from this information we are fetching the description of each case using the case ID. So this is the page where we can add the case ID and we get the case history. So a small summary and description is being given for each case. So this acts as we apply natural language processing methods on this description to identify for our analysis, and I'll be taking you through the analysis that we did. So we have scraped the descriptions from here, taking the case ID from this data. This file has almost 1.5 million rows, so those many cases, so only for Kansas City, so that all the zip codes around Kansas City, that served as a very good rich source of data for us. The initial analysis that we did is the number of cases for each zip code, and this is the average resolution time for each zip code. It is based upon the all the 1.5 million data. We have filtered it from 2015 though. This is the past 5 years data, and the graphs you can see here for each of the categories like air quality, animals, pets, bridge. These are the categories that are part of 311 cases. So whenever a person calls 311 and he can uh, lodge a complaint saying something about nuisance or facility, so those will be categorized while taking note in the 311 on the 311 side of it. And these are the plots for the same resolution time for each of those categories. So if we see the same thing for zip code wise, let's see the zip code wise results. So these are the zip code wise results. For each zip code we have plotted the top issues that the zip code is facing, and with the number of cases in each zip code with for each of those uh, categories, each type of the issue. So that is the initial analysis we did, and this is how it looks like. If you see the map with the number of cases for each of the zip codes. So this is the map of Kansas City and the neighboring zip codes in Missouri. So these are the number of cases plotted for each zip code. So our analysis continues with the description. So the next part is handled by Charan, where he analyzed the descriptions with and predicted the department and identified department based upon the description. So the category and department with BERT have been, the predictions are based on BERT. So we give descriptions as input, and we can identify the category to which the particular description corresponds to, and the department should handle this 311 call. So the description can be from anywhere through call or email or Twitter or from the website, or it can be from um, in other sources mentioned in the dataset. So after we figure out the department and category, we did the time series analysis using Facebook Prophet. Prophet is a library in Python which provides automated time series forecasting for data. It has been we have employed a few other techniques like using LSTM, RNN, and LSM with memory and with the window technique and all, but we found that Facebook Prophet gave a better accuracy or lower mean average error, and we went with that. And that is for time series. Coming to question answering, we have used Albert, which is Lightbird for self-supervised learning of language representations from Google AI. So we use it for question answering, asking the questions like who is reporting the issue, what is the issue being reported, where is the issue being reported, I mean, where is the issue, where did the issue happen, why does this problem happen. So asking these questions gives us answers that can be identified from the description and provided for further analysis. So that this is how it looks like, the Albert model. So we have trained it on our own data, and it has been performing well. So these are the questions that we have asked. And then coming to the topic modeling, so we have used LDA and BERT to identify the topics. These are the 16 topics that we have identified. So apart from the category and department, this is how the machine understands what's going on in the description of the cases. So on a top level, we can identify into corresponding to the given categories. We can see that this falls into trash. Topic 6 falls into trash. So there are a few parallels that we can draw between these topics. LD and Bert has identified, and like the agents, 311 call agents have identified. So we have put all of this together as a dashboard where you can interactively check the number of cases in each zip code and the corresponding categories, and the number of cases in each category and the cases in each category. And you can also check out the case history with the provided link, and also the time series analysis for a particular zip code from 2008. And these are the predictions so if you select a case, these are the predictions that it says. It should be because it has trash. It has identified that this category should be trash and the department should be municipality, what should be handling this case, and the resolution time has been identified as 84 hours. So uh, as a part of the feature work, we'll be adding this into the visual analysis as well, and also we'll be providing interactive live predictions for 311 cases as they arrive from different sources. So we hope you liked it. Thank you.